Lesson 3-5, solve inequalities using multiplication. In this video, we want to solve inequalities using the property of the multiplication property of inequalities, and then we want to also graph the solution sets. But here's some rules we need to keep in mind. So the multiplication property of inequalities says if A is less than B and C is positive, then A times C is still going to be less than BC. So let's say A is going to be, we'll say A is going to be 2, B is going to be 3, and C, we'll say C is going to be 4. So if A is already less than B, because 2 is less than 3, we know that 2 times 4 is still going to be less than 3 times 4, because this is going to be 8 and this is going to be 12, and 8 is still less than 12. But if A is less than B and C is negative, then AC is going to be greater than BC. So now they're saying if C is negative 4. So that means if I use those same numbers, so if I have 2 times negative 4, and then I have 3 times negative 4, it's now going to be flipped. The symbol's going to be flipped because negative 8 is actually bigger than negative 12. So just remember, when you multiply by a negative, you're going to flip the symbol, because now the number that used to be the smaller number is now going to be a bigger number, and the number who was the smallest is now going to be the biggest. So just remember, flip the symbol when you multiply by a negative number, when you're dealing with inequalities, that is. So let's look at an example. We're going to solve and graph this inequality. So the opposite of dividing by 5 is going to be multiplying both sides by 5. So if I do that, I'm going to have C on this side, because the 5's divide out, is still less than or equal to 13 times 5 is going to be 65. Now I'm not flipping the symbol because there is no negative that I'm multiplying by. Now to graph this, we're just going to have our number line here. We have 65 here. Because it can equal 65, I have a filled in circle. Less than means it goes to the left. Next, I have P divided by negative 3 is less than 12. The opposite of divided by negative 3 is multiplying by negative 3. So I do that on this side, that divides out, and I'm left with P is still, I'm going to wait for the symbol yet. Since I'm multiplying by a negative 3, I multiply this side by a negative 3. Now I flip the symbol, so now it's greater than 12 times negative 3 is negative 36. And then to graph it on a number line, I have negative 36 here. It cannot equal negative 36, so it's an open circle. Greater than means it goes to the right. Now if I want to verify that my answer is correct and my graph is correct, I just choose a number that's bigger than negative 36. I'm going to choose 0. 0 divided by negative 3 is 0. 0 is still less than 12. Therefore, I know my inequality and my graph is correct. Next, solve and graph this one. Here, A divided by 7. The opposite of dividing by 7 is multiplying by 7. So I multiply by 7 on both sides. I'm now left with A is greater than or equal to 4 times 7, which is 28. To graph it, got 28 here. It cannot equal, or it can equal 28, so it's a filled in circle. It has to be greater than or equal to, greater than goes to the right. And if I want to verify this one, a number bigger than 28, and I want to make sure that it's divisible by 7, because I'm going to have to divide by 7. So I'm going to say 35. 35 divided by 7 is 5. 5 is still greater than or equal to 4. So I know that my answer is correct. Here, 4 is less than or equal to r divided by negative 6. I want to multiply by negative 6 on both sides to get r by itself. Because I'm multiplying by a negative number, I now flip the symbol. So right now I have negative 24 is greater than or equal to r. Now if you don't like it writing it that way, I'm going to write it the other way with the variable first. So r is less than or equal to a negative 24. Now somebody might say you didn't flip the symbol. I actually did flip the symbol, even though it looks like the original one. But because I wrote the variable first, and if I read the original problem backwards, r divided by negative 6 is greater than or equal to 4. Now I have r is less than or equal to negative 24. So now we graph it. We have negative 24 here. It can equal negative 24, so it's a filled-in circle, has to be less than, so it goes to the left. And if I want to just verify it, I need a number less than negative 24. I want to choose one that's divisible by negative 6, so I'm going to choose negative 30. Negative 30 divided by negative 6 is 5. 5 is greater than 4. So I know that my graph in inequality is correct. A couple other examples. Here I want to get y by itself, so the opposite of divided by 4 is multiplied by 4. Do that on both sides, and I'm left with y is greater than 44. To graph it, got 44 here. It cannot equal it, so it's an open circle. Greater than means it goes to the right. This one, p divided by 2 is less than or equal to 12. The opposite of dividing by 2 is multiplied by 2. So if I multiply both sides by 2, now left with p is less than or equal to 24. So on a number line, you got 24 here. It can equal 24, so it's a filled-in circle. It's got to be less than, so it goes to the left. And our last one. Here I have 25 is less than or equal, less than n divided by negative 5. If you don't like it when it's written this way, just rewrite it. So this would be n divided by negative 5 is greater than 25. Same problem, it's just I put it in reverse order. So multiply by negative 5 on both sides. Negative 5 divide out here. And because I'm multiplying by a negative, I flip the symbol, so it's less than. 25 times negative 5 is negative 125. Now I choose a number, or actually put a number line, so negative 125 cannot equal it, so it's an open circle. Less than goes to the left. Now just to verify that it's correct, number smaller than negative 125, but I want to make sure that's divisible by negative 5. I'm going to choose a negative 130. And if I take on negative 130, negative 130 divided by negative 5 is 26. And 26 is greater than 25. Therefore, my graph and my inequality is correct. So that is our lesson on solving inequalities using multiplication.